Hello world, I'm Declan McClintock. Today I'm going to talk to you about clean code and some related topics. This set of slides was made for a presentation for Spartasoft, Michigan State University's Game Development Club. So, while these slides are useful in a general programming context, they will lean towards programming in a game development context. So, what exactly is clean code? To me, clean code is code which is readable and understandable by less experienced parties than the one who originally wrote the code. Someone should be able to understand what the code is doing and how it is used in as little time as possible. If you can have your mom, dad, or even your grandparents read your code once and understand what your code is supposed to be doing, you might be doing a decent job. Why should you spend precious time creating clean code? Well, firstly, writing clean code saves time overall. You won't be wasting your own time or someone else's when you or they have to figure out what the code does. Secondly, clean code is easier to modify and extend. The easier the code is to understand, the easier it is to change. Thirdly, you and your coworkers are going to enjoy working with your code more. No more looking at month-old code and going, "Who wrote this crap?" Oh wait, that was me. I know you're excited to write some clean code, but you need to know how to do it. So we are going to go over some ways to make your code cleaner. Use variable names that represent the values stored in the variables. Basically, use descriptive names. No more one-letter variables. Instead, use a name that is long enough to describe the value stored, but short enough to avoid being overly verbose. Keep to a coding standard. It doesn't matter which coding standard you use, but when you pick one, you should consider what the industry standard is, as well as what your team is used to. Use comments as needed. You might think that adding a bunch of comments makes your code more understandable, but too many comments can make your code more difficult to read and harder to understand. Your code should be self-documenting if your variable names, function names, and class names are descriptive. You should use comments for function headers, class headers, and anywhere else additional explanation is needed. You should avoid flooding your code with unnecessary comments. Avoid zombie code. Code that does nothing but sit around and rot away your integrity as a programmer. Zombie code is most often large blocks of commented out code that gets left behind. When you comment out code to try another solution, you should always clean up after you find what works. Stay dry, or don't repeat yourself. If you find yourself copying certain lines of code, you should probably make a function that you can call instead. If you don't stay dry, your code will be wet, and you don't want that. Avoid abbreviations. We have the power and the storage space. We don't need abbreviations anymore. Avoid going deeper than 3 indentations, or what's known as arrow code. The deeper your indentation goes, the more needlessly complex your code gets. When you find yourself going past 3 indentations, it's a pretty good sign you should make another function or class to handle what you're doing. Follow the principle of proximity. You should keep related code together and try to have your code read from top to bottom. I like to think of my code as a well-written essay for an English class. Don't be proud of hacky code. Your code might be complicated in doing what it's supposed to, but that doesn't make it good. What does make it good is if it is understandable and working. Avoid being overly verbose. Most of us like to talk a lot, but that doesn't mean we should. Use whitespace as a tool for readability. You don't need 1 to 3 lines of white space between every line of code. You also don't want 0 lines of white space. You have to strike a balance that keeps your code readable. When you are naming your classes, try to use a noun. Make the name specific. You want to avoid general names that could mean a lot of things, such as manager. Also, make sure your classes do one thing or as few things as possible to keep them manageable. Avoid being string typed. If you're going to use strings to represent types of a class, have them be constants inside the class itself that you can compare to. Avoid magic numbers. You don't want numbers floating around in your code. Most every time you would use a number in your code, it makes sense to have it be stored in a variable somewhere instead of hard-coded. Don't put all your variables at the top of your code. Instead, put them near where they are used. Review each other's code. If you're working on your own, find someone you trust to do code reviews for you. Doing this is important because it shares knowledge and leads to more readable code. Try to program in pairs. Doing pair programming elevates both persons' skills and improves the quality of the code. Now that we've gone through clean code, we're going to touch on a few related topics. Firstly, I want to talk about strings. You can do pretty much anything with strings, but you shouldn't do everything. One good thing you can do with strings is store information as text. One bad thing you can do with strings is use them to represent booleans or numbers. One thing you should keep in mind when considering using strings to solve a problem is that string processing is slow. Refactoring. Refactoring is essentially rewriting existing code to make it easier to work with or more efficient. Generally, you aren't changing the code's input or output, just its innards. You might hate doing refactoring, but I've found that the more I do it, the more I like to do it, and the more I appreciate it, as it makes life easier later. You should consider refactoring code if you will have to work with the code is difficult to understand, or the code is difficult to change. And generally, you should always clean up after yourself. Analysis and synthesis. Analysis is the process of breaking down a larger problem into smaller problems. Synthesis is the process of taking solutions created for those smaller problems and piecing them together to address the larger problem. Now, this is more of a software engineering concept than a clean code one, but I've found that doing analysis leads to better understanding of the problem domain and thus cleaner code written to address the problem. We will do a quick analysis and synthesis for the game of checkers as an example. What programming problems do we have to address when making checkers? What do we write code to do? Assuming we aren't writing any of the graphical code and are instead using an existing engine like Unity 3D or Unreal, we might consider piece movement, turn management, sound effect playback, visual effect playback, camera movement, and possibly a few other things. Now, we don't stop after the first level of analysis. In fact, we might have to do analysis any number of times. But we do have to stop somewhere, and knowing where to stop is important. You should stop doing analysis when you reach a problem that produces a general solution when solved. This solution should work for all subproblems underneath it. If it doesn't, you need to do analysis again. Going from our checkers example, just enough division would be piece movement divided into regular pieces and kinged pieces. Too much division would be dividing regular pieces into each individual piece on the board. We don't need a class per piece to govern their movement. We can have one class that works for all regular pieces. Improving yourself is important. Here are a few things you can do to become a better programmer. Challenge yourself. Do tutorials on topics you find difficult. You can find programming tutorials on Unity's website, YouTube, and other places around the web. If you want things in a lecture-style format and aren't against spending money, Pluralsight is also a good place to look. Keep a journal or two. Write out logic for how you might solve a problem. Write out class hierarchies to design systems. You can fill it with anything, so long as you fill it. You'll find that writing things down helps get your ideas flowing. Observe your favorite games and try to reproduce what they do. If you aren't a gamer, you could do the same thing with other software products more in line with your interests. Communicate. Talking things out will help you solve all sorts of problems. Eventually, you will work with someone you don't like. Finding a way to like them will help you have more fun and be more productive. Talking through your logic with someone will help you debug your code. Rubber duck debugging is also useful. The more you communicate with your team, the more work you will get done, and the more you will learn. Applying this information for non-programmers. You can think of clean code as a sort of best practices for programmers. Similarly, there are best practices for every other discipline. You should ask a more experienced person in your discipline about best practices, but from a game programming point of view, here are some of the things I consider important. For 3D modeling, don't use default names, be specific with your names, and freeze your transforms. For 2D art, use layering and name your layers descriptively. For design, be prepared to innovate and change. Don't be the idea person. You need to be able to do more. Do be a person doing research on related games to what you are making, and do encourage and facilitate communication across your team. That's all I have for clean code and related topics, but you can stick around if you want a few more bits of advice. Taking a step back from your work is useful for getting a fresh perspective. When you go too deep into one thing, you will start to lose focus on the broader picture, and this can lead to poorly written code. If you can catch yourself when you become too focused on one small part, take a step back and think about how to continue. Respect everyone. It doesn't matter if you want to, and it doesn't matter if they deserve it. Treating everyone with respect makes them more likely to listen to your input. In the professional world, you'll have to treat everyone with respect anyway, so it's best to get in the practice of doing it now. Using agile methods. Build a backlog of tasks that need to be done for the completion of the project. Try to keep the tasks as bite-sized as possible. Also, keep in mind these agile methods can feasibly be applied to more than just the programming team. Determine a sprint length. This is typically 1 or 2 weeks' time. Assign tasks from the backlog at the beginning of each sprint to members of the team. Assign tasks based on how much each individual member can accomplish in that sprint. Address task completion at the end of each sprint with the team. Have each member present their work. If you finish a task early, grab another task from the backlog. That's finally all of the slides. Thank you for sticking with me. I hope you learned something, and if you'd like to know more about me, you can check out my website, declanmcclintock.com.